We often look at a pond or a river and just see, well, a mirror reflecting the sky, right? But beneath those ripples, there's a highly structured, literal engine running. Welcome to The Explainer. Today, we're diving way below the surface to uncover the dynamic, hidden mechanics of our local lakes, rivers, and ponds. We're going to unpack exactly how these complex ecosystems function from the top down. So, here's our diving itinerary for today. We'll start with the science of limnology, compare lentic and lotic habitats, map out the water zones, look at limiting factors for life, meet the benthic bottom dwellers, and finally, check out the riparian buffer zone.
All right, Section 1, the science of limnology.
Limnology, it's a specialized subcategory of ecology focused purely on freshwater ecosystems. When we talk about this field, we're looking really closely at the profound ways organisms interact with their specific environments. We're talking lakes, ponds, rivers, streams, springs, wetlands, the whole shebang. It's not just about the water itself, right? It's about the entire living, breathing system functioning within it.
Moving on to Section 2, lentic versus lotic habitats.
Now, this divide is absolutely fundamental. On one hand, we have standing, relatively still water localized in a basin. Think of your classic lake or pond. Then, on the other hand, we have water with a current, moving continuously in one general direction, like a river. These physical states dictate entirely different rules for survival. I mean, a fish evolved for a calm, lentic basin would seriously struggle to survive in a rushing, lotic river. It's kind of like putting a couch potato on a treadmill. To make these scientific terms really stick, just look at their Latin roots. Lentic comes from lentis, which actually translates to sluggish, perfect for those calm, still water habitats, right? Lotic, on the other hand, comes from lotus, meaning to wash. That perfectly captures the essence of running water habitats washing over the rocks. So just remember, lentis is sluggish, lotus is washing. Section 3, mapping the water zones. Okay, so if we map a lake, the crucial thing to understand is how it splits the aquatic habitat based entirely on depth and light penetration. This isn't just arbitrary geography. It's quite literally a map of energy. The sun is the primary engine here. How far its light can effectively pierce through the water column determines exactly what kind of zone you're dealing with. Let's break those down. First, at the shallow edges, we have the littoral zone. This is simply the shallow area where sunlight penetrates all the way to the bottom. Swim past the drop-off, though, and you're in the limnetic zone. This is the open water where the sun still hits effectively. It's the critical sweet spot where photosynthesis perfectly balances respiration. But if you plunge past the reach of the sun, you've entered the dark, deep, profundal zone. There's just no effective light down there at all. Section 4, limiting factors for life. Survival in these zones is basically governed by 5 major limiting factors. Think of them as the bouncers of the ecosystem. You've got temperature stability, which decides if organisms can even survive. You've got currents that distribute vital gases. Then there are the respiratory gases themselves, like oxygen and carbon dioxide, which honestly are very often the primary limiting factors for life. We also have biogenic salts. Things like nitrates and phosphates limit most freshwater systems, while calcium is absolutely critical in softwater habitats. And finally, the water's transparency. To measure that transparency out in the real world, scientists use something called a Secchi disk. They basically drop this disk directly down into the water column to see how deep it can go before it completely disappears from sight. This measures turbidity, which is often caused by suspended clay and silt particles blocking the light. Think about it. If the light gets blocked, that limnetic zone we just talked about actually shrinks, and the whole energy balance of the lake totally changes. It's all connected. Section 5, the benthic bottom dwellers. Down in the dark, we meet the benthos. By definition, benthos are the hardy organisms attached to, resting on, or living directly within the bottom sediments. This is the absolute floor of the freshwater ecosystem, guys. They act as the ultimate recycling crew, usually broken down into filter feeders, like clams, and deposit feeders. Here's a perfect real-world example of that. A snail acting as a deposit feeder. It isn't swimming freely through the open limnetic zone. Nope, it's making its living right there on the bottom sediments, just resting on the floor and feeding off the organic deposits that literally rain down from the upper zones of the habitat. It's just perfectly adapted to its specific spatial layer. Section 6, the riparian buffer zone. Emerging from the deep water and those bottom sediments, we finally hit the edge where the aquatic world meets the land. We call this edge the riparian zone. The word riparian comes from the Latin ripa, meaning riverbank,
But more importantly, this vegetated area acts as a vital buffer strip. Its job is incredibly important. It shades the water and physically protects the fragile stream from the impact of whatever is happening on the adjacent land. When you picture a cross-section of this boundary, you have the uplands stepping down into the floodplain. Those deep tree roots and thick brush, they're actively holding the bankful elevation together. They're filtering out runoff before it hits the water and shading the aquatic zone right in the center. It's the ultimate protective shield for the delicate systems we've just spent our time exploring. As we leave the water behind for today, I want to leave you with one final provocative thought. If the stability of this entire aquatic zone, the transparency, the temperature, the very survival of the benthos at the bottom, relies so heavily on that protective riparian bank, how easily could our everyday actions up on the dry land disrupt this incredibly fragile, interconnected freshwater machine? It really makes you rethink how you view the water's edge, doesn't it? Thanks for joining me on this explainer. Until next time, keep looking beneath the surface.